Alright, so I've got our scratch stage set up here, and I've plotted a few points, the four edge points and the middle point for 0, 0. And I just wanted to explore what exactly it means to go outside the bounds of the stage of scratch. Alright, so let's just explore this real quickly. Okay, so I've got my phone here, so we can kind of see what it means to line this up. Right now it's lined up with the stage as if this is the stage. So what we're going to pretend is that this phone represents this actual stage, right? So you can barely see the borders, and we know that 0, 0 is at the middle of the screen. Now, when you plot a new point, it's going to be at, like, say, right there we've got our 100 coordinate, or something like that. Now, we want to move things outside the stage. So say we've got a point all the way over here. I don't know, maybe this is like 300x, and then this is almost, this is like 170y, maybe. So right, it's all the way off to the right side of the screen. So it's outside of the scratch's bounds. So you're not actually seeing it on the camera here, right? You're not actually seeing it on the phone screen. So what we need to do is we need to pretend like we set up our phone as a variable, okay? So our phone's x and y position right now are 0, 0 because that is the center of the phone. But what happens if we move our phone screen over just a bit? Right, so now our new phone screen center is maybe right below this point. Right there, that's the middle of our phone screen. So that's maybe 290, and then that's a little less, so maybe 150. Right, so now we have our actual phone's position. Let me just do that one more time. Screen over 0, 0, and then as I move my whole phone this way, it's going to look like this point is moving the opposite direction in the phone. Now I'll make the screen bigger so you can see that, but when I move the phone to the right, it looks like the point 0, 0 moves to the left. Now this is an important fact because we're going to actually do some math that uses subtraction, and when you first look at it, it's going to be like, wait, why is it moving the opposite direction? But it's actually not moving the opposite direction. It's just you have to think about your camera versus your object, right? So if your object is at 0, 0, and you say, hey, I want to move my camera around, maybe I want to move my camera up this time. Now, on the screen, it looks like the object moved down, but what actually happened was the camera moved up. So you're going to have that weird, interesting thing that you could just kind of have to wrap your mind around. But if your object moves up with your camera, it almost looks like it's not moving at all in the screen. It looks like it's fixed in there. And that is very important when you get to games that have something at the very middle of the screen, like in Pokemon or something like that. And then everything else, the whole world moves around it. That's what it looks like, right? So if I'm just moving these together and it looks like nothing's moving, and when I drag it all the way through, you see all these points move, but it doesn't look like the actual sprite is moving. And I'm calling this magnet right here the actual sprite. So that's a very interesting thing, and we're going to go code that up in Scratch. So I'll see you guys over there. Alright, let's get started and just make this scrolling project. I think it's going to be a lot of fun. Okay, so the first thing we're going to need to do is set up this camera variable. So let's make two variables, one for the camera X position, and we're going to make this for all sprites. Let me rename that camera, not camera, camera X position, and another one for the camera Y position, again for all sprites. So this will keep track of the coordinates of the camera, because currently our stage, which I'm going to call the camera from now on, doesn't have a position. It's just kind of always at the center. So we're going to create that, and we're going to make it so we can control these with the arrow keys. Okay, so let's just make sure to set them both to 0 when we start up. Let me make this bigger so you can see it. Oh, whoops. Let me just drag out two of these blocks. One for the camera X position, one for Y. We're just going to set them both to 0. Okay, next thing we're going to do is set up a little control thing here. So forever, and we're going to do if. Go to sensing, grab our key space, press. We're going to do up arrow. And we want to make sure that it controls the camera. So if you haven't watched the basic player movement controller video, that will help you here. And we're just going to set that up like this. We're going to have 4 of these, just duplicating that. So we're going to go up, down, left, and right. Okay, and when we go up, we need to make sure Y increases. I'm going to do 10. And when we go down, make sure y decreases, so minus 10. We go left, make sure x, right, because x goes by negative 10, because that's this way. And right should also be camera x, and that should be positive 10. Whoops, positive 10. Okay, cool. So now we've got this set up. Let's see what happens when we press our up arrow key. Whoa, those numbers are really big. Okay, so sometimes things happen like that. Now those numbers are increasing so quickly because Scratch is moving as fast as it can. So why don't we just, sometimes this happens, not all the time, but we just get a wait 0 seconds. Okay. Now if I press up, okay, cool, that's much better. That only happens sometimes in Scratch, remember, like usually very rarely. Okay, but this is looking good. If I move left, it goes negative on the X. If I move right, it goes positive on the X. And yeah, up and down and work as well. Okay, so now we can control our camera. Of course, it's not doing anything, it's just numbers. But we want to set up a very similar thing for our cat object as well. Okay, so currently we have the X and Y position, but that represents where our cat is on the screen. So we want a way to store, we need to store the information of where the cat is actually in the world. Because if you notice, say I just change X to by 100, if I double click on this a couple times, it stops at 271. So he's actually limited with his position because that's a relative to the screen. So I'm going to make a new variable called the cat X. I'm going to do for this sprite only because it belongs to the cat only. And this will be important, especially if you're dealing with clones, which we will in a minute. And cat Y for this sprite only. Okay, so now our cat has its own X and Y world position, right? Kind of on the whole map that I drew out, he's got a position. And we're going to start out just setting those to 0. So we've got our cat X to 0 and our cat Y to 0. And now we want to be able to do some stuff. Okay, so for right now, we're just going to say go to the cat's X and Y position. And that makes sense, right? Right now we're just fiddling with it, so just go to that position, and it just acts like the same variable, except it can have a larger number. Okay, but now we want to be able to control our cat, not with the arrow keys, but with the W, A, S, and D keys. So we're going to set up a very similar thing to what we did in the stage for the camera, and we're going to grab our forever and our if block and our key pressed block, and we're going to do this time W, A, S, and D, and we're going to grab our change variable block in there, duplicate this 4 times. Okay, so we've got W is for up, S is for down, A is for left, and D is for right. Okay, so up is cat Y, that should be by 10. Down is cat Y, that should be by negative 10. Left is for cat X, that should be negative 10. And right is for cat X as well, and that should be positive 10. Okay, so now we have a way to control our cat and our camera. Of course, it's just numbers for the camera, but our cat will actually move. So right now I'm pressing up, and now, yeah, you can just see that the cat is moving. We control the variables, but because we're just going to that same position, it's also updating his position here. Okay? So you notice that we can keep on moving off the edge of the screen, and this number gets bigger, but he's still stuck right there. So this extends our reach outside of the screen, which is really nice. Of course, we're going to need to do some more things to edit this. All right, so now we can control our cat, but now we want to make our camera actually affect the position of the cat. And it's a really simple operation. All you need to do is grab a minus block from the operators tab, and then get your camera position. We're actually going to make 2 of these, one for the X and one for the Y. And you're just going to put it like this. All right, so we've got our cat's X position minus our camera's X position, and our cat's Y position minus the camera's Y position. And the reason for this is because if they're both at the same position, then when you subtract them out, it's going to be 0. So the cat's going to be in the middle of the screen. This will make more sense when we fiddle with it. But yeah, it's not that hard to wrap your head around. I'll put up a graphic so you can maybe see how that works. Okay, so now that we've made it, we should just run it and make sure it works all fine. So I can move my cat around. I'm going to put him near the center again. Now I'm going to move my camera. I'm moving my camera up. Remember, because I move my camera up, it looks like the cat is falling down, but that's not actually the case. The camera moves separately. Hopefully that representation with my phone helps make sense of what's actually going on here, but they're two separate objects. Okay, so now that we can control the camera and the cat, let's make it even more obvious by making a new sprite. So what I'm going to do is stop everything. I'm going to duplicate our cat. Because I duplicated our cat, we have a second one with all of the same variables and stuff. But I'm just going to rename the cat X and cat Y to be grass X and grass Y. And there should still be private variables. Let me just check it off and show you that it's still a local variable. So that's exactly what we want because we're going to make clones. Okay, so now we have grass X and grass Y. Oh, and we don't need this whole chunk here because we don't want to control our grass with buttons. We just want our grass to stay on the ground. Okay, so now we've got this. Let's make sure that we actually get some grass objects going. Let's go to vector because I like vector. Choose a nice green and then make some sprouts. Beautiful. Okay, so that's our little tiny grass costume there. And right now it just goes to the center of the screen. So if I run this, oh, we don't want the grass to show on top of our cat. Just go back in there. Okay, that should be fine. Okay, so now it's behind our cat. If I move my cat out of the way, you'll see. If I move my camera up, you'll see they both go down, and they both follow the opposite direction of the camera movement. Okay. Now, what happens if I move my cat and a camera at the same time? I'm going to press the up arrow and the W key at the same time. Okay, well okay, something's off right there. It looks like our cat's moving faster than our camera. Now, remember when I said to put this wait 0 seconds block in there? I think that was just because we only had variables, but now because we actually have go-tos and stuff, it's messing that up. So grab that wait 0 seconds block and get rid of it. I know it's really finicky and I don't even completely understand it myself, but just get rid of that. So now it should work as expected. So press the up arrow and the W key at the same time. And I'm pressing down with them. And it looks like the cat's not even moving. And it's like he's following the camera. But if you look at the grass, it's moving behind him. Now this will become much clearer when we have a bunch of grass. So let's create some clones. Now the clones are going to do exactly the same thing as the regular grass object, except we want them to go to random positions. Okay. Now, because we're not restricted to just the stage, we can make them random anything, right? So we can do like -1000 to 1000 on the X position, and then like -500 to 500 on the Y position, and that will still work. Okay, let's create these clones. Let's just do it right here. I'm going to do it on a new block. Okay, so when flagged click, repeat, let's make what, 200 clones, and just create clone of myself. Alright, let's see what happens there. You'll see a bunch of clones popping around, a bunch of grass. You'll see it's building up at the edges, so we're going to have to fix that because things kind of get stuck on the edges of Scratch, so we'll just have to make sure to hide it or show it if it's off the screen. Okay, so now I can move my cat around just like normal, looks good. Okay, but if I move my camera around, you can see it kind of makes more sense what's happening. It's kind of scrolling around. But if I move my camera and my cat at the same time, now it really looks familiar. This kind of looks like, whoops, this kind of looks like something like you'd see in a video game, right? If they move together, the whole background moves behind them, kind of like in Pokemon or something. Okay, so that is really cool. Now, if you wanted to achieve that effect, like in Pokemon or something, all you would need to do is make both the camera and the cat controlled by the same one. So let me do that real quick. Instead of this one being W, A, S, and D, let's change that to, I'm going to duplicate it and disconnect it so that we can save this for later. But I'm just going to change it to up, down, left, and right. Okay. So that's disconnected, so we're not controlling with those, we're controlling both the cat and the camera with the same inputs. Okay, so if I run this, then the cat's always going to be at the middle. WASD don't work, but if I press the arrow keys, then it looks awesome. It looks like our cat is walking around in this world, and we've got so much grass and awesome things. So that's how you can achieve that effect. I'll leave this plugged in so you can see that. All right, so now we want to make sure that our grass disappears, because you can see it's really piling up on the edges of the screen. So there's just some simple math that we can do. It might be a little bit complicated for some people, but that's okay. So we just want to make sure that both the X and Y position of the object are on the screen. So that's why we're going to use an and. We want to make sure both the X and the Y. X and Y. Okay, so we want to make sure they're on the screen. So I'm just going to do this a simple way. I'm going to use a less than block. And I'm going to use this block right here. It says square root. I'm going to change that to ABS, which stands for absolute value. And I'm going to plug in the X and Y positions accordingly. Okay, so what the absolute value block does is, here, I'll pull one over here off to the side. If you didn't see the math video, we can explain this. So say our cat's position was 100, so that's on the screen. If I double click it, it gives us 100, so it's the same number. But if it's negative 100, then it gives us a positive number. So no matter, so it's symmetrical, right? So if it pulls off of this side of the screen or this side of the screen, then it pretends like it's just one number. Because it's symmetrical, we can use this, and that's really nice because if our X position is less than what our X position can go to 240, so if it's the absolute value is less than 240, then we're on the screen. We also want to make sure our Y position is less than 180 to make sure we're on the screen. So if we're on the screen, then we're going to show, otherwise we're going to hide. Okay, does that make sense? This means we're on the screen, this means we're off the screen. And we're also going to want to copy this block for our original grass object too. So these are basically the same thing. Okay, so now we can run this, and some grass will pile up. Okay, and we can control our cat. All right, so now you notice that it's working for the most part. Let me just check. Okay, so you'll see that it's not really working entirely, right? Because it's building up at the top of the screen, but the other sides look pretty good. And the reason for this is because Scratch's image system is kind of weird, because the center of the image can kind of change its position. So instead of going with the blue position, we're going to go with what we created, our grass's X position. Okay, so we're going to go, instead of that, we're just going to copy these blocks straight down, right? Okay, I hope that makes sense. That's the position that it should be if it's in the world, right? Because that's where we're going to. So if you just drop those in there, everything should work very well. Let's just let the grass appear. Okay, and you notice they're not building up in the edges so much. We've got grass in random positions, and I can move around, and you can see there's a lot up there and a lot over here, but they're not piling up in the edges. So for any object that you create, you'll want to just pretty much just copy this code and put that in that object if you want it to scroll in the world. And yeah, I mean, that's pretty much it. You may need to fiddle with these numbers. The bigger the object is, it might look like it's popping off the screen. So if you have like a big background, which you could totally do with a bunch of clones, you could create a background. You might want to change these numbers a bit, but that's yeah, that's about it. We created a scrolling project. It didn't take too long. We can control the arrow keys. Right now it controls both the cat and the camera at the same time, but we can separate those to control them separately. And yeah, if you ever want to make grass move, all you need to do is change these two variables that we create. So thank you so much for watching. I hope you got something from this. I hope it's starting to make sense what's going on here, especially in just conceptually with how things are moving. Not necessarily all of the math and stuff. Maybe not this math, but hopefully this go-to block makes sense. All right, I'll see you guys in the next one.